Um, you guys gave a great introduction. I don't really have to say much. So this panel really is all about the students. And I think one of the things that we've often talked about in ACETA is seeing students innovate, seeing students really take their education, put it into practice. And one thing that um, has come out of this pandemic is seeing actually, as Sid was saying, students getting innovative and working around the problem. And the way that this panel is structured is that I will get out of the way and we'll basically have our panelists be our students, and some are current students, some are former students, and they've stepped forward from their academic education to start startups. Some are ongoing in grad school and still doing things. Some are student orgs like Sid mentioned. And what we're gonna do is for each student group, like circuit design you're seeing right now, we're gonna do is have them present just about a minute, 1 to 2 minutes, and then it's going to be a 5-minute Q&A. And so we'll go through the session that way. And then at the end, during the birds of a feather discussion, we'll break out so that each group will be able to have more intimate time with any of the audience. They can share about their startup, or they can share about their club. And hopefully it opens up collaborations. Hopefully it opens up dialogue. But a big thing to keep in mind is that the questions that we've asked them to address, there are essentially 3 questions. We want to know, what is it that you're presenting? So what is circuit design? What makes it special? What made you come up with this, especially during the time of the pandemic? How did you actually work on this? That's one of the main questions. The other 2 questions really was, how did your EC education facilitate your capabilities here? How did we enable you? But also, where was it lacking? Where do you wish you had more education? Where do you wish you had more maybe hands-on, or maybe more theoretical knowledge that you never had, and you had to kind of supplement at 2 a.m. like Shane was saying. So keep that in mind as they're presenting, and definitely try to engage with them in discussion during the Birds of a Feather session. But other than that, I guess, Austin, it's all yours. Do you want to click the link for him? Is it Megan running the show? I'm not sure who's in the background.
Yeah, Megan's got control here.
I believe it should be linked in the slide, right?
We're just playing the presentation video, correct?
Yes.
Okay, cool.
Unless you memorized it and you want to replay it again.
I didn't. I'd prefer to go with the video.
I think it probably popped up on another screen, so she's pulling it up. There it is.
There we
go. Megan, I believe you have to share your audio when you're sharing screen,
yeah.
Otherwise it won't come through.
Sorry, we practiced this earlier and we're just having some little issues, so let me fix that fast.
Live demos, they always do that.
Hi, I'm Austin, and I'm a co-founder of Circuit Design, along with my colleague Zen. I'm very excited to introduce you to our startup, as well as the circuit design software we're developing, Circuit Studio. Circuit Studio is an application for circuit design that will incorporate all of the steps, from initial schematic design and simulation, to breadboard prototyping and final PCB layout, into a single user-friendly workflow. Our goal is to enable students, hobbyists, and semi-professionals to fully prototype their own electronic circuits without needing years of experience with complex circuit design software. While Circuit Studio is expanding to support all of these steps in circuit design, from conceptualization through PCB, we've initially begun as an application that excels at circuit diagramming, allowing users to quickly and easily compile realistic circuit diagrams. I was largely inspired to build Circuit Studio as a result of my undergraduate ECE education. My education introduced me to the process of circuit design and industry tools, and it provoked me to further explore and master these tools such as Altium Designer and SPICE Simulation. In doing so, I had the realization that building electronics requires years of experience, and even with that experience, the process, which involves many different tools, is quite cumbersome. Bringing this back to my undergrad experience, I believe that I really would have benefited from an introductory electronics course that gave students the full experience from initial circuit design all the way through PCB manufacturing in a single semester. Such a course would give much more context to the full EE curriculum and would really help to captivate students who are still deciding on their major. I believe that Circuit Studio would make this possible as a beginner-friendly, one-stop shop for the entire circuit design process.
Okay, Austin, excellent. I have a question for you. Have you thought about introducing Circuit Studio as at the end, you mentioned it being part of curriculum. Have you considered using it as part of some kind of workshop programs in schools?
Absolutely. We're targeting our software both for hobbyists, but also in the educational context. We haven't explored this entirely yet, but we're definitely open to any sort of workshop or even structuring a course around our software. Does that answer your question?
Yes. Yeah, yeah.
Okay, cool.
All right, I won't hog it though. Questions from the audience.
Austin, oh, go ahead, Randall. Sorry about that. You know, I'm going to be a fan.
Well, I was just wondering, Austin, was your expectation when you went into school that it would be hands-on or theory? What was the emphasis? Did you think it would be both? What was your expectation on entry and then the realization of what?
Yeah. So I was very entrepreneurial, even like at the end of high school and entering college. And I had a bunch of hardware-based ideas I wanted to be able to build. And I came in freshman year hoping I would be able to get that skill set really quickly, and maybe by sophomore year be able to prototype some of these ideas. But in reality, it ended up not being until junior, senior year before the pieces even remotely started to come together, where I had experience with all the different tools and the entire circuit design process. So I wanted it to be really hands-on, and I really wanted to be able to get that full scope of the process just as early as possible.
So when you went in, there's a technician's degree from technical colleges. That's a 2-year degree. And then there's a technologist degree, electrical engineering technology, which would be a 4-year degree from a technical college. And then there's the engineer's degree with master's and PhD at the university setting. Did you consider the technologist schools?
Not entirely. I just hadn't really been introduced to that as an alternative path. So I did the 4-year bachelor's in electrical and computer science, but that was kind of just what was laid out to me.
Yeah.
So that's the path that I took.
And so what's interesting though is that the expectation is that the engineer's degree is a hands-on as opposed to the theory of electrical engineering and things like that.
Exactly. Yeah.
Okay. Thanks.
Mm-hmm.
I just wanted to give you big kudos, Austin, for getting your head around this issue. It's something I spoke briefly on yesterday. So when you talk about the circuit design to the board design to manufacturing, sort of what was your impetus there? And what was sort of lacking sort of in those bridge points, say between circuit design and then into PCB design and then to manufacturing? Like what was missing for you, and how did you put these things together?
Absolutely. So for myself, I've always seen when I'm reading online, watching videos, that in the professional setting, they go directly from a schematic to a PCB, maybe with some sort of SPICE simulation in between. But I've now been developing professional circuits for a couple of years now. And every time, the process I go through is I'll design a schematic, I'll go to a breadboard first. So you have to procure a specific set of components for the breadboard. Then I'll iterate this to maybe a 2-layer PCB, which has like a 3-day turnaround. Again, hand soldering these things. If that works, then I'll finally go to a 4-layer professional PCB, have that fabbed in China, fully assembled. The process to me is very iterative though, and it didn't feel like there's any software that was really succinctly accomplishing or streamlining that process. And I think that sort of plays into the hobbyist and educational setting too. There's a lot of emphasis on the breadboard. It's just, at least from what I saw, it was currently like very left out from professional software out there. So that's sort of where my mindset came from trying to tackle this problem.
And any thoughts on programs like Autodesk Eagle or KiCad? Did you find those also? Because those are targeted more at the hobbyist space. And, you know, what were the pieces specifically?
So I actually haven't used those. I've actually used Altium a lot though. I actually used Altium to design a lot of these professional PCBs and had a great experience with it. I think the gap though is that Altium, at least for myself, it took a long time to master. It's very powerful, but it took a long time to master. And I think, at least for introductory students, it's a big hurdle to overcome.
Okay, thank you. I was curious about the hobbyists because there are some out there, and you know what sort of inspired you to jump in that space. And I agree with you, by the way. It's a powerful, Altium is a powerful tool, and there are some offerings out there. But anyways, kudos to you, and kudos to you for really identifying that problem and seeing an opportunity for students. I think that's really, really valuable.
Thank you very much.
All right. Any other questions for Austin? Or excellent work, Austin, by the way. I'm really curious to see what when are you expecting the feature, the simulation and the PCB features to be out?
Yeah, I'm thinking over the next 6 to 12 months. I'll wrap this up very shortly. We're focusing very much on circuit design and diagramming right now and perfecting that. But I think over the next 6 to 12 months, we should have a lot of the overall workflow implemented and released to the public.
Great. All right. So
And
next,
Austin, congratulations. Sorry if I'm interrupting, but seeing you go from somebody who did a senior design in machine learning of a music composition to a hardware is a great journey. Congratulations. Yeah.
Thank you, Sid.
so next up we have Patrick from Duke Electric. We will also play a video from Penn Electric because they're quite related, but because of our time constraints, we actually won't be able to do Q&A with both. But they will each have their own breakout session. So you're welcome to interact with them there.
What if a car could drive anywhere on Earth on the equivalent of 1 gallon of gas? That's 14,500 miles per gallon. Students on the Duke Electric Vehicles team at the Pratt School of Engineering have built that car, powered by a hydrogen fuel cell. They call him Maxwell. And guess what? Maxwell and the students just broke the Guinness World Record for most fuel-efficient vehicle. That's outrageous ambition. That's teamwork. That's knowledge in action. That's fueling the future. That's energy at Duke.
Awesome. Thank you. So as a quick introduction, hi, I'm Patrick. I was the leader of that team. That video made us look much more professional than we were. And I'm just going to quickly tell about the story. So I did an electrical engineering at ECE at Duke, and now I'm doing a PhD in robotics at Georgia Tech. And so that was our world record vehicle powered by a hydrogen fuel cell, and currently holds the Guinness World Record for like 14,500 miles per gallon. So I think just to loop back to the engineering education, I had a ton of fun at Duke. It was a lot of fun to get to work with everyone. And I think in particular, Duke ECE was great because everyone was super motivated. There were lots of like resources and tools available, and everyone, like all the faculty, all the staff, everyone wanted to help us. And also there was a lot of fun. There was funding available, which is a necessary part of projects like this. One thing I will say that I wish could have been done a little bit more is like project-based labs or hands-on practical experience, open-ended experience in particular. Because although I think I got my fair dose of hands-on education in the club, I think a lot of other students didn't perhaps get quite the level of depth that I got. So that's the one thing I would improve. But yeah, I'd love to answer any questions about education or the vehicle or any of that.
Patrick, congratulations. This is unbelievable that you guys can build this. How big is the team, Patrick, and how expensive is it to make this car?
The team was about 15 to 20 people. This world record was broken over the summer, so there are only a few kids there over the summer. The funding, I guess just to say the numbers, I think our team had about $50,000 of funding every academic year, and we got it from a variety of sources that Duke helped us find. So
I have a facetious question. Being from Texas, if you crank the AC in that car, what kind of mileage do you get?
So that car consumes about 20 watts of power to make it go, and an air conditioner in a passenger vehicle consumes about 4 or 5 kilowatts. So yeah, to run an air conditioner, it consumes more 100 times more power. So yeah, not good.
Patrick, you made the point that you had quite a bit of hands-on education, obviously, but you think that in general students didn't. What made that experience different for you?
I think I was part of this club for my 4 years at Duke, and I was also part of a few other like engineering clubs. And I really love working with my hands, designing the circuits and yeah, laying out PCBs and getting them fab and soldering them together. And I think a lot of people on the team got that experience as well. Though I would say like one of the problems we had is when recruiting, even when recruiting, like sophomores or juniors or seniors to our team, like a lot of them didn't quite have the same hands-on experience. So I think the club is awesome because it gives everyone a great goal to work towards. But yeah, I wish everyone could have that experience.
But Patrick, what's really cool is the watts, the numbers. I don't think many engineers in college understand this relationship between numbers and power and the energy that's needed. I think that connection itself is just so good for students to know what energy actually means in terms of watts. So that's fantastic.
Patrick,
Yeah,
oh, go ahead, Patrick, sorry.
There are a couple of really interesting stories, and yeah, converting like joules and like moles of hydrogen and like the the charge of an electron. When's the last time you used that in an equation? Like fitting all these crazy constants we learn about in class together in an equation. It was pretty cool to see it work.
So Patrick, you and Austin both mentioned the same idea that you wanted to dive in to hands-on projects or doing things or being well prepared in advance to make innovative devices like solar cars or PCBs in your freshman and your sophomore year, right? And one of the things that I struggle with looking at our sophomore circuits class is students are trying to figure out, resistor networks and getting used to all the simultaneous linear equations and lots of theory. Do you have any examples of some projects you think could help jumpstart students into being able to build a PCB, but without using, transistors or big complicated FPGAs and Verilog code? How could we get them started on a project early that helps lead them into these student-based project groups that have really big things they're trying to solve, but with starting skills at a freshman level or sophomore, early sophomore?
Yeah, in my personal opinion, the Arduino and similar microcontrollers, man, they're like so easy to learn, and because everything is just 5 volts and it just kind of works when you plug it in. Like you can like the digital stuff, at least in my opinion, like people pick up pretty quickly, and then you can have like a more complex digital side drive a simpler analog side as the kids are learning, but then the analog gets more and more complex. But yeah, I think the Arduino is like pretty intuitive and like easy to learn, so I think that's a good starting point.
Yeah, I totally agree with that. I think with the Arduino, all of the IoT modules are very recipe based. So I think it's a great place to start where they can be like, okay, I want to build a project and I can think conceptually about the different modules that I want to select for the project. And because it's so recipe based, you can basically plug those in and have those automatically connected to the Arduino without needing to understand the theory of Wi-Fi communication or something like that.
I'd like to politely cue in to let Duke Electric know that it's time for our next group to speak. Thank you, Patrick, for your time.
Yeah, thank you guys.
So just as a reminder, we won't have time for Q&A for Penn Electric, but they will have a breakout session. So we'll just show their video and then jump to the next one. Sorry, Sid, we're not discriminating.
Hi, my name is Monal Permar, founder and CEO of Educational Vision Technologies. My company spun out of my senior design project at UCSD, where I was an electrical engineering student. We specialize in automated AI video editing and online course creation. The first service we created was a device which goes in a classroom and automatically creates online courses. For board-based classes, it extracts all the writing from the whiteboards and chalkboards to generate notes just like a human note taker would. During the pandemic, we created a new service which enhances uploaded videos such as Zoom recordings, splits a long-form video by the topic that you can scroll through and quickly find the relevant information. The ECE education at UCSD was very helpful because I specialize in signal processing and machine learning, and that helped to create the core algorithms for our products. What was lacking in the education? I would say that more management, learning how to manage a team of engineers, gaining confidence to network with others and build more meaningful relationships. And the last thing that was lacking, I would say, is a community for more diverse students. First in my family to go to college, and having more support of others.
Manal, did your video cut off short, or was that how it was supposed to end?
Yeah, I trimmed it. I trimmed it to kind of fit closer to that 1 minute mark. But yeah, the last piece was on the whole piece of better able to find a community of people that have a more similar background to you, because that's important in making you see yourself as an engineer, or helping you see yourself as an engineer.
Yeah, that's an excellent point. I'll give a little bit of background for you guys. So I've known Manal for a very long time, and I still remember when he was walking around with his prototypes of just a hardware rig. And during the pandemic, they've done a tremendous shift and have just gone from trying to push that as a product to now really offering a software suite that helps in remote education. So big plus to you, Manal.
Thanks.
Just a quick question. That text extraction from the whiteboard or the blackboard is super cool. How does that work?
Thanks. Sure. Yeah. So we have a device that goes in the classroom. It works with any standard whiteboard or chalkboard. And some of the boards we've worked with were giant. Like one of the classrooms, the chalkboard was 50 foot wide. It detects writing, follows the professor, segments the professor out, segments the writing out, does denoising. So our systems learned what chalk dust is, does all the filtering, denoising, and then based on numerous heuristics, this organizes the writing into a 8x11 format, just like a human note taker would.
Oh, that's really cool.
Manal, sorry, I missed the title of the name of the software package. Is that something we can find and Google online?
Yeah, you can. I'll post the so our website's ebt.ai. And yeah, we have two offerings. A device, it's using the NVIDIA Jetson, and it's doing computer vision in real time as the lecture goes on to do the video processing and curate content. And then we have EVT Bloom, which just enhances uploaded videos. So it takes like a long form video, and it automatically does the editing, because it's if you're given a 2 hour long video, it's a pain to go through the video content, especially if you have a visual impairment. So our system automatically generates a table of content. So then for a blind student, for example, can listen to the subtopics in the video. So let's say there's a math lecture, and then it's broken down into double integrals, triple integrals. And then the blind student can listen to the table of contents we automatically generate, and based on that, decide what part of the video to play back. So it's really, there's thousands of hours of content that universities create for lectures, and having professional video editors edit all these thousands of hours is not very feasible. So you really need AI at scale to do all this editing.
Oh no, this is fantastic. Congratulations.
Thank you.
What's the cost of the regular cameras in a classroom, the video feed is okay. All you need is a video file to input to your system?
Yes. Yeah. So we have two services, one where it's like an actual device that goes in a room. And then the other service is where you upload your videos. For the EVT Bloom, where you upload your videos, the cost for our highest tier package is about $33 per hour for video editing. And as a reference, video editors often charge $80 an hour
for video editing. So it's more than half as cheap as humans. And the amount of value you get for it, you get actually just really briefly, I'm gonna share my screen. So this is actually a CETA talk with HKN. And so our system, we uploaded this, and our system split up the slide presentation per slide. You can click on a slide and start the presentation at that point in time. It also, after a presentation, there's Q&A. And so our system splits up the presentation per speaker, and it automatically generates a summary of what each speaker said. So instead of trying to like skip through a 30-minute discussion to see like what's of interest to you, if you only have like 5 minutes, you can basically just read a summary and based on that decide what part of the discussion to jump into. And yeah, this is all, you get a speech transcription, you can search through the speech, and does the editing, and it's unlimited users. So it doesn't matter if you have 1,000 people watching, it's all the same price. And at the biggest tier we have, it's $33 per hour.
Thank you. Well, this is amazing.
This
And
is-
I guess, yeah, sorry, Judy, go ahead. Yeah.
No, I'm just echoing what you said. I think it's amazing. So a question I had for you, Manal, is this is amazing technology. What is your go-to-market strategy, and how are you doing with sort of adoption? And is your primary market the education market?
Yeah, great questions. And so like Ramson mentioned, we initially started with the device, and then during the pandemic, we shifted to processing the uploaded videos. So initially we were focused on STEM education in higher education and universities. And we have a few departments at UCSD, math department, physics, electrical engineering, that are using our platform and system. So during the pandemic, when we shifted to developing the Bloom service, we had to pause on our marketing outreach to more focus on R&D. So we finished development in April. So right now we're doing outreach to universities. We're doing outreach to universities, we're doing outreach to universities initially, but we do see applications in conferences, corporate training. So the go-to-market is something that we're currently actively working on. And I'd love to get anyone's thoughts around where you see this of use. I was told that IEEE conferences could make use of the service. And so I'm very open to learning about where you see our services applicable.
The second part of that question is some transcription models aren't that great. Like, how is the accuracy on the transcription of what the speakers are saying, say in a Zoom meeting?
Yeah, so the transcription is it's good if there's no domain specific vocabulary, like Schrodinger, it's not going to get that right. Or there's no accents. So it's not very accurate if there's accents. Accuracy over the years improves. All the computer vision we do in-house, but the speech transcription, we use Google's premium speech transcription model. But yeah, we've seen it improve over the years. And yeah, I think that's just with the recent advances in AI, it's like it's going to just only continue to increase. And I think pretty soon accents probably won't even be an issue.
Hi, I'd like to interject real quick. Manal, thank you so much for your time. We have to move on to the next group. So excellent.
That was really cool.
And I'll remind you guys, we have the breakout sessions where you'll have full time ask all these questions there too. Thanks, Kevin.
OccuSpace is the world's easiest occupancy data solution. We measure how many people are in a space in real time, whether it's a gym, restaurant, or office, and then provide this data back to both the visitors and the space owners in order to improve their experience and maximize the space usage. We do this by installing sensors that pick up Bluetooth and Wi-Fi signals from people's electronic devices, and then a proprietary AI analyzes that data in order to obtain up to 98% accuracy in our people count estimations. My ECE education helped me build a framework for solving any problem. It consists of 4 steps: measuring the problem and collecting some data on it, analyzing this data in order to build a model that attempts to explain the problem, and then finally testing and tweaking the model and repeating as needed until a solution is achieved. I wouldn't say that anything was ever lacking in my EC education. And I think the one thing that UC San Diego does that is super important was its focus on product engineering. Its emphasis on coming up with products that are feasible and readily available to go to market.
So I'll start, Linus. I would just like to ask, during the pandemic, has your, since we're talking about go-to-market strategy, has your perspective shifted at OccuSpace from what you initially started out with, and then obviously when we went remote, how did the focus of OccuSpace shift in accordance with that?
Absolutely. Thanks for asking, Ramzan. So in the beginning of the pandemic, our main focus was just trying to provide people with occupancy data because they were concerned about their space capacities. You know, as spaces were reopening, or some people had to come into work, you know, they wanted to have a lot of control over how many people were in their space. And so that's kind of how they came to OccuSpace, came to us to try to provide them with that solution. But then as things started to reopen and the pandemic started ending, the focus shifted, and people saw also the value of our data for really the space utilization aspect of things. So really understanding how your office spaces or your libraries or your gyms are being utilized in order to optimize future construction projects, future design or reutilization projects. So it was interesting to see that we had to stay very lean and also not just focus on really the COVID aspect of our solution.
Is the pricing model based on the cost of the individual modules as well as a subscription for analysis?
Yeah, so the pricing module is we lease our devices at $300 per year, and that includes all of our products. So we have a dashboard where space owners can measure their data, obtain reports, see heat maps of how different segments of their spaces. And then we also provide universities with an app where students can then see the live occupancy of their library, of their gym, and then make their day-to-day decisions according to it.
You have a question in chat asking what technology was used for sending. I can see millimeter wave cost. So that in the video you briefly mentioned Bluetooth and Wi-Fi. Maybe you want to talk about millimeter wave?
Yeah, we briefly considered using millimeter wave technology, but to this day it's still very costly. Some of our competitors use it, where they just install millimeter wave sensors on top of doorways. Others use cameras. We saw that wanting to be the easiest occupancy data solution, we didn't want to be attached to really the infrastructure aspect that millimeter wave and vision takes, where like you have to install the sensor at a very specific location. Ours, you can just install it in any outlet. Plus the cost of just a Bluetooth and Wi-Fi sensor, which is what we have, is 5 to 8 times cheaper than a millimeter wave sensor or a camera-based solution.
I'd like to politely come in and say thank you so much for your time, Linus. Ready for next group.
Thank you.
I'm an incoming master's student at Georgia Tech, and I'm here today to talk about StrideLink. StrideLink is a gait tracking wearable that me and my team have been working on to help objectify data in physical therapy. We did this by making a wearable that can strap onto your shoe and can then collect data outside of the clinic, where a physical therapist cannot be there. My EC education helped in developing this, especially with the upper level courses such as embedded systems. There I learned how to connect modules together, power management, and how to program a microcontroller. But I feel like where my EC education lacked a little bit was really the timing in which this information reached me. I wish I had been exposed to a lot of this stuff in my earlier level courses, beyond just programming a basic Arduino, but putting together a whole system with power, with casing, a lot of relevant skills that go into making a product. I really only got this towards the end of my 4-year degree at Georgia Tech in the CreateX class, where we take an idea and we convert it into a product. But I feel like if a lot of the earlier classes had this kind of concept beyond just programming, it would really cultivate a tinkering space where people would be trying to make things and innovate. And I think that would be a really good addition to the ECE programs.
Hi everyone, I'm Neil. You guys have, and I can maybe show the device because I didn't show in the video.
Yeah, hi Neil, this is Patrick. Yeah, I guess you skimmed over pretty quickly what the device is and what it does. Yeah.
Yeah,
say a little
yeah, I
more,
can
that'd be
talk
cool.
about it a little bit more. So we designed a custom PCB, which is pretty simple actually. It has an accelerometer on board that we just collect the data from and write it to an SD card for now. And then after we collect that data, we post-process it afterwards to extract the gait data. So different phases of gait. So for example, one is like heel strike or like toe off. Gait cycle has a lot of different phases to it. And if you look at variations between those phases and like there's certain expectations, like for example, the percent of time swinging in the gait cycle is maybe like 20%. We can look at that data and see irregularities in the gait and help identify problems in a person's gait. So we give data as a therapist and we give it to them on a dashboard for them to process. And the device itself like fits on a shoe like this. One goes on each shoe. And so we can get left and right foot data and see the differences between, you know, if your left foot's limping, maybe the gait looks a lot different than your right foot's. I hope that if that answered your question, if it didn't, let me know and I can talk more about it.
Yeah, that's pretty cool.
So Neil, you mentioned full system integration as something that you wished you'd learned earlier in your career. So I can picture, you know, calculating what the bus drop is on various power supplies, maybe the size of the PCB versus the size of the shoe box that you want to put on top of it. Are there any other things you can think of that we should try and integrate into courses and projects in the classroom for students to kind of explore that space? Things you struggle with?
Yeah, a lot of the stuff, well, particularly for me, CAD was a big struggle, which I guess I'm a computer engineer, so it isn't like a hard requirement, I guess. But I feel like CAD is something that is useful to at least have the basics in for any engineering degree. I was kind of thrown into it in my junior design class where we had to, like, we CAD'd up a Christmas tree where it was spinning and all that, and with like gears, and taking that in one semester was like kind of overwhelming. So I feel like if I had an introductory course in that, but also kind of like Patrick was saying, like an introduction to microcontrollers earlier, something as simple as an Arduino would have been really good just to kind of open up my mind to the possibilities of what you can do early on.
Thanks.
So it's totally by just luck that you happened to bring up this topic, because I did want to end on this subject and kind of make everyone think about it when we go into the breakout rooms. But something that Sid and I were talking about was the fact that oftentimes our educational systems relegate this experiential learning to your senior design and capstone classes. And I've heard, Neil, you kind of hit it right on, but everybody else has kind of been talking about it in sort of circumspect ways. But the idea of trying to get students exposed early on to easy prototyping, to just giving them inspiration to see what they could do, seems to be a kind of a theme that resonates with all of you, and for sure with me as well. I wanted to be tinkering when I was in second grade. So really great that you brought that up. I promise I didn't coach him or anything to say that. So thank you, Neil. And Kevin, if you want to, you want to add any thoughts and thank yous before we transition to Birds of a Feather?